So friends, today we'll discuss the alkanes topic. So what is meant by alkane? Alkanes are the simplest organic compound. They are made up of carbon and hydrogen only. They contain only one carbon and hydrogen atom. That's why we are considering as a carbon and hydrogen atom bond and carbon bonds. And it is single covalent bond. They are joined together by the single covalent bond. That's why we are considered as alkane. Then molecular formula for the alkane is CnH2n plus 2. Why are calling this CnH2n plus 2? Means if the compound contains only one carbon atom, the hydrogen should be 4. We'll have the formula for this. One is methane. Methane has one carbon atom, hydrogen atom 4. So the formula we will put it into this formula. See, only one carbon is there and then hydrogen 4. How it will come 4 hydrogen atom? So carbon is 1. So 2 into 1 plus 2, that is 4. That's why 4 hydrogen should be coming in the methane. And if you are converting into ethane, ethane has 2 carbon atoms. So how many hydrogen should be required to produce satisfied structure? There are 6. Why it is? Because 2 carbon atoms are there. 2 into 2, 4. 4 plus 2, 6. Hence ethane contains 6 hydrogen atom and 2 carbon atom. They are also called as saturated hydrocarbons. And these are the carbon atoms or the hydrocarbons relatively unreactive. That's why it is required very drastic condition to undergo the reaction. And it is also called as paraffins. Why you are calling paraffins? Because para in the sense param and affins in the sense little activity. That's why it is does not undergo the reaction. And we will have the one example, methane. Methane has the 4 hydrogen atom and middle side the carbon atom, and ethane has 2 carbon atom and 6 hydrogen atom. So this is the alkane, and we have the sp3 hybridization of alkane. Initially we will write the electronic configuration of carbon atom. In the ground state, carbon has the 6 electron. We'll put into the formula 1s to 2s to 2p 2, and we will write the electrons in that x, y, z. So 1 electron means p orbital contain only 2 electrons. Then it will goes to the excited state. So this 1 electron will be shifted towards this. So it will produce excited state configuration like 1s2, 2s1, 2p1, 2py and 2pz. So this 3p orbital combines with the 1s orbital, that is called as sp3 orbitals. Hence 4 new orbitals will be arises for the alkane. 1 2s and 3 2p orbitals give 4 new sp3 hybrid orbital. These 4 new sp3 hybrid orbital arranged in the space in a such a way that their axes are directed towards the corner of regular tetrahedral angle. We'll have the methane compound, and carbon is sp3 hybrid compound, and 1 s orbitals will binds with the 4 hydrogen atom that will forms s sp3 sigma bonds. Then ethane, sp3 hybrid orbital of carbon atom overlap with the sp3 hybrid orbital of another carbon atom, and remaining 3 valency or remaining 3 sp3 hybrid orbitals binds with the hydrogen atom, that is 1s orbital of hydrogen atom, to form s sp3 sigma bonds. So that is the sp3 hybridization of methane and ethane. Then we will have the structures. So this is the methane structure. This is central carbon atom and hydrogen atoms are there, and the bond angle is 109.5. So this is the sp3 hybrid orbital, sp3 and sp3, and to that sp3 hybrid orbital we have attached 1s hydrogen atom, 1s hydrogen atom. So this is the methane. Then we'll have the ethane structure. So this is the sp3 hybrid carbon atom will binds with the another sp3 hybrid carbon atom, and remaining 3 sp3 hybrid orbital overlap with the hydrogen atom by binding with the 1s orbital, by binding with the 1s orbital. Same will be performed by this carbon atom. So this is the ethane structure. One carbon atom overlaps with the another carbon atom by the sp3 hybrid orbital, and the remaining 3 sp3 hybrid orbital binds with the 1s orbital of hydrogen atom, and it is the sp3 hybridization. Then we will have the next structure, that is alkenes. So alkenes are the hydrocarbon that contains carbon-carbon double bond. That's why we are calling alkenes. Molecular formula for the alkene is CnH2n. Cn is equal to number of carbon atom. Alkenes are commonly known as olefins, and we will have the various examples for the alkenes. Ethylene having 2 carbon atom, they are bonded to each other by the double bond. Then butane has the 4 carbon atom, they are bonded to each other. First carbon is bonded to each other by the double bond, that's why we are calling 1-butene. Means double bond is present at the first and second carbon atom, we are calling 1-butene. Then 2-butene means double bond present at the second and third carbon atom, that's why we are calling 2-butene. Then we will have the sp2 hybridization of ethylene. So ethylene contained carbon is sp2 hybridized carbon atom. They are attached to each other by sigma and pi bond, and sigma bond result from the overlapping of sp2 hybrid orbital with the carbon atom of another sp2 hybrid orbital, and pi bond is formed by overlapping of unhybridized p orbitals, and remaining sp2 hybrid orbital make the bond with the hydrogen atom. So this is the ethylene structure. One carbon binds with the another carbon atom by sigma bond sp2. And then pi bonds will be produced between the pi orbital. So this is the pi orbital, this is the pi orbitals, they are joined together, and remaining 2 valency will be joined by the hydrogen atom. 1s orbital of hydrogen binds with the sp2 hybridized carbon atom. This 1s hydrogen binds with another sp2 hybridized carbon atom. That is sp2 hybridization of ethene or ethylene. Then we will discuss the preparation methods for alkanes. There are 7 methods are then. First is hydrogenation of alkanes or alkynes. Second, reduction of alkyl halides. Third, decarboxylation of carboxylic acid. And fourth, hydrolysis of Grignard reagent. Fifth, action of sodium on alkyl halides, that is Wurtz reaction or Wurtz synthesis. Then sixth, Corey-House alkene synthesis. And seventh one, electrolysis of salt of carboxylic acid, that is Kolbe method. And we will discuss one by one hydrogenation of alkenes or alkynes. Hydrogenation in the sense addition of hydrogen atom. So addition of hydrogen atom means reduction. So we are performing reduction in presence of nickel, palladium. So many catalysts we are using. So it will produce alkane. Initially reduction of alkene to form alkene. We will discuss the reaction. So alkene can be prepared by catalytic hydrogenation of unsaturated hydrocarbon in presence of catalyst nickel and platinum at the 200 to 300 degrees centigrade. So we have taken alkene. Alkene means the compound which contains carbon-carbon double bond. We have treated with the nickel as reducing agent. So addition of hydrogen will proceed. So one hydrogen will goes there and one hydrogen will goes to there to form alkane. Then we will take the one example, propene, treated with the reducing agent. So hydrogen addition leads to formation of propane. So this is the formation of alkane from the alkene. Then we will see the reduction of alkyne. So we will take the alkyne treated with the 2 molecules of hydrogen atom, and nickel is the catalyst. We are getting alkane. An example, methyl acetylene treated with the 2 molecules of hydrogen atom in presence of nickel to form propane. And second method, reduction of alkyl halides. So alkyl halides treated with the zinc in HCl, that is a reducing agent. So H2 is going to treat it 1H and this X liberated as HX, and 1H from this attaches to the alkyl group to form alkane. So alkyl halide undergoes reduction in presence of nascent hydrogen and reducing agent, that is called as zinc in HCl to form alkane. So we have taken methyl iodide treated with the zinc in HCl to form methane and hydrogen iodide. That is second method. Third method, decarboxylation of carboxylic acid. So carboxylic acid salt or sodium salt of carboxylic acid treated with the sodium hydroxide, and initially it will produce the alkane. How it will, we will see. So Na2CO3 will be combined together to form Na2CO3, and this hydrogen atom goes to there to form alkene. So we will have the example, sodium acetate treated with the sodium hydroxide and to form methane. So this will be removed, carbonyl group will be removed by the NaOH, and Na2CO3 will be formed. Na2CO3 will be formed and hydrogen atom will be migrated towards this to form alkane. So I have taken one example also. Then fourth method, hydrolysis of Grignard reagent. Initially we will see the how the Grignard reagent is going to produce. When alkyl halide treated with the magnesium in presence of dry ether to form alkyl magnesium halide, that is Grignard reagent. Then we will treat the Grignard reagent with the water. So hydrogen goes to this R group and MgOH will be liberated as a byproduct. So this is the hydrolysis of Grignard reagent to form alkane. We'll have the one example, methyl magnesium iodide treated with the water. Hydrogen goes to there to form methane and MgIOH is the byproduct. Then fifth method, Wurtz reaction or Wurtz synthesis. Two molecules of alkyl halide treated with the sodium atom in presence of ether. So R group attaches to this R group to form symmetrical alkane with the liberation of NaX. That is called as Wurtz reaction. The product should contain even number of carbon atom. That is Wurtz reaction. We have taken one example, methyl bromide treated with the sodium, two molecules of methyl bromide. So it is undergoes reaction in presence of ether. So CH3 migrated towards this to form ethane, and Na and this Br migrated as NaBr. That is the Wurtz synthesis. Then Corey-House alkane synthesis. So we have taken ethyl halide or ethyl chlorine treated with the lithium to form ethyl lithium. Ethyl lithium treated with the copper iodide to form lithium copper ethyl group, and this undergoes treated with the ethyl chloride to form butane. So this is the production of butane from the ethyl chloride. And then last one is Kolbe synthesis, that is called as electrolysis. Sodium salt of acid treated with the water in presence of electric current or electrolysis, and it is to form alkane, and carbon dioxide and NaOH is liberated. That is Kolbe electrolysis method. And we will see the reactions of alkane. There are substitution reactions will be there. First one, halogenation, nitration and sulfonation. So this is the substitution reaction. And thermal and catalytic reaction, in that oxidation, pyrolysis, isomerization and aromatization. So these are the major reactions. We will see the various substitution reaction. Electrophilic substitution reaction we will see. Electrophile means the compound which has the positive charge on it, and it will abstract the electron atom from the other source. That is called as electrophile. And substitution means hydrogen atom is replaced by the chlorine, fluorine, bromine, iodine or sulfonil or nitrite. That is why we are calling electrophilic substitution reaction. Thermal and catalytic reaction means here we are using temperature. Also we are performing oxidation in presence of catalyst. Also we are performing air oxidation. That is called as thermal and catalytic reaction. There are four reactions we will discuss: oxidation, pyrolysis, isomerization and aromatization. Then first reaction, halogenation. So we'll treat the methane in presence of chlorine in presence of UV light. So chlorine migrated towards this to form methyl chloride, and chlorine and one hydrogen from this to form HCl. We'll have the mechanism also. Cl broken into Cl and Cl with the help of HV light, that is UV light. Next is chain propagation. This Cl tries to attack on the methane. The hydrogen will be liberated as HCl, and CH3 group is remaining, and this CH3 group abstract the chlorine atom from this to form methyl chloride. That is the mechanism for the halogenation reaction. Next, nitration reaction. So alkene treated with the nitric acid at 400 to 500 degrees centigrade. It undergoes nitration reaction, means NO2 is migrated towards alkyl group and HNO is liberated as water molecule. So this is the alkene treated with the nitrous acid to form nitroalkane. We'll have the one example, methane treated with the nitric acid to form nitromethane, and water is the byproduct. The mechanism: initial ionization of nitrous acid or nitric acid to form NO2 and OH- ion. And the next chain propagation state, CH3 is going to ionize H and CH3. CH3 and NO2 tries to attract to each other to form nitromethane, and H and this OH combines together to form water molecule. That is nitration mechanism. Then next is sulfonation reaction. This involves treatment of alkane with the sulfuric acid. So SO3 group will be migrated towards this, and hydrogen migrated towards this to water form. This involves substitution of hydrogen atom of alkane by the SO3H. When prolonged reaction of alkane with the fuming H2SO4 to give alkane sulfonic acid. So this is the alkane treated with the fuming sulfuric acid to form alkane sulfonic acid, and water is the byproduct. And next is combustion or oxidation. So pentane is going to oxidize to form carbon dioxide and water molecule. The general formula will have the for balancing of reaction CXHY plus XY divided by 4 into O2 is XCO2 and Y divided by 2H2 and heat. So we'll apply the reaction and we'll get the product carbon dioxide and water molecule. Then pyrolysis means breaking or deaggregation of the compound with the help of heat. Decomposition of the compound by heat is called as pyrolysis. This process when applied to alkane, that is called as cracking. Larger alkanes are broken into mixture of lower molecule of alkanes and hydrogen. So this is the ethane treated at 500 degrees centigrade in absence of air. It will produce the alkene initially, and 1 molecule of methane, 2 molecules of methane will be separated, and hydrogen is going to produce. Then pyrolysis mechanism, CH3CH3 is going to form the methyl radical, 2 molecules of methyl radical. Methyl radical abstract the proton atom from this to form methane. CH3 and CH2 will be liberated, and CH3 and CH2 will remove the hydrogen atom to form ethene. That is pyrolysis. 6. Isomerization. Isomerization means shifting of carbon atom. Normal alkanes are converted into branch chain isomers in presence of aluminum chloride and HCl. So n-butane converted into isobutane. So this is n-butane treated with aluminum chloride and HCl to form isobutane. Last one is aromatization. Alkane containing 6 to 10 carbon atom converted into benzene and homologous compound at high temperature in the presence of catalyst. So an hexane passed over chromium trioxide supported over alumina at 600 degrees centigrade temperature to form benzene. So this is the n-hexane treated with the chromium trioxide in aluminum trioxide at 600 degrees centigrade temperature and atmospheric pressure to form benzene, and hydrogen is going to liberate. We discuss uses of paraffins. Paraffins widely used as a fuel for jet engines or rockets, and fuel for the diesel, also for the tractor engine. Paraffins is widely used in the heating oil or for heating of oil, and liquid paraffin is used as a lubricant for the machinery, and it is commonly used to treat the dry skin, constipation and eczema. Then paraffin wax is also used for the water harvesting of soil treatment to supply runoff water to dry the areas as adhesive and waterproofing agent. Thank you very much for watching my video. Thank you.